Section 2.2, Functions and Graphs. So we need to identify functions. What is a function? A function is a correspondence between a first set called the domain and a second set called the range, such that each member of the domain corresponds to exactly one member of the range. So let's think about some examples that meet that definition. What about a grocery item? Every grocery item in the domain is corresponding to one and only one price in the range. So in other words, if you buy a gallon of milk at the grocery store this week, today, if you go in today and buy a gallon of milk, you expect there to be one and only one price that is associated with it. If you were in the checkout line and you rang the milk up and 1 gallon cost $1.50 and another gallon cost $2, you'd have a problem with it. If you're bringing up your groceries, you expect a gallon of milk to be associated with one and only one price. A function makes a lot of sense. We expect there for every member of the domain there to be one and only one member that corresponds in the range. Letter on a phone dial. So the letter A. If you are looking for the number that is associated with the letter A, that's the number 2. It's always the number 2. So a letter on the phone dial, the letter J is associated with the number 5. It's always associated with the number 5. So if somebody says, my phone number is call me, there is one and only one number. That's not enough letters, but there's one and only one phone number that would be associated with that. Is this a function? Domain and range. For every element of the domain, it should correspond to one and only one member of the range. A 5 in the domain is corresponding to a 2 in the range. A 2 in the domain, a 4 in the range. An 8, a 9. Yes, that's a function. What about this one? This one, you have 1 in the domain that corresponds to a 1 sometimes. Sometimes it corresponds to a -1. You have one element of the domain corresponding to 2 different elements in the range. You cannot have that with a function. If you put in a 1, you always want to get the same thing out. I don't care if it's 1 or -1, but you only want one single correspondence. 2, you put the 2 in, you get a -2 out, that's fine. This represents the problem. So no, it is not a function. Let's look at New York. New York is our domain. The range could be the Giants, could be the Jets. You put in New York, sometimes you get the Giants, sometimes you get the Jets. That is not a function. It does not correspond to a function. One element of the domain gives us 2 different answers in the range. This one, the domain is the Giants. That gives you New York. The domain, an element of the domain, is the Jets. That gives you New York. Is that a problem? No, that's fine. You put in the Giants, you always get New York. You put in the Jets, you always get New York. Each element of the domain is associated with only one element of the range. You put in the Cowboys, you get Dallas. That is a function. So is this a function? The domain, the members of class. Correspondence, each member's social security number, which gives us the range, a set of very specific numbers. Does each person in the class have an association or a correspondence to one and only one social security number? If I ask you what your social security number is, you probably are going to give me one and only one social security number. You only are supposed to have one social security number. Yes, that's a function. Members of the class, is there a one-to-one, or is there for each member of the class, do they have one and only one credit card number? No. There are many members of the class who may have 2 or even more different credit card numbers. So you have one member of the class associated with 2, 3, 4 credit card numbers. So that is not a function. The correspondence where each member of the domain has to be associated with one and only one member of the range. That is not a function. So most functions in mathematics are described by equations like y equals 3x minus 1 or y equals x squared minus 7. When an algebraic expression describes the correspondence, the notation f of x equals some algebraic expression is used. So it is read as f is a function that pairs with each value of x in the domain the value obtained when that x is substituted into the expression, or more simply, f of x. It's very important that you realize that that is read f of x, a function of x. It is not f times x. It is f of x. It's function notation. So instead of y equals 3x minus 1, we will write f of x is 3x minus 1. Why do we do that? Well, for two reasons. It emphasizes that this is a function. It also emphasizes that something is happening to x. The domain is usually a representation of all x values. So this emphasizes that something is happening to the domain. It doesn't always have to be f of x. It could be h of x, g of x, but f of x is the most commonly used. When x equals 0, what is y? Another way to say that is, what is f of 0? F of 0. X is in the parentheses. It says x is 0, so we want to know what is f of 0. So what do? What is f of 0? It is what happens to what is in the parentheses. Look at this. F of x. What happens? It says what happens to x? You multiply 3 times x minus 1. So what happens if 0 is in the parentheses? It's like fill in the blank. We have 3 times whatever's in the parentheses, 0, minus 1. 3 times 0 is 0 minus 1, which is just negative 1. So it becomes a fill-in-the-blank type of situation. What is f when x equals 5? What is y? That means f of 5. What is f of 5? X is 5, so that's what we put in the parentheses. What is the function of f evaluated for x equals 5? F of 5 is 3 times whatever's in the parentheses minus 1. In this case, it's 3 times 5 minus 1. So 15 minus 1 is 14. That was one way we had of defining f of x, but here's another definition for f of x. This time, f of x is 4x minus 5. So forget about that last f of x. We have a new one. And we have a g of x, 3x squared minus x. What happens to x that's in the parentheses? Well, if it's f of x, it's 4x minus 5. What happens to x if it's g of x? It's 3 times whatever's in the parentheses squared minus whatever is in the parentheses. So f of 2 is 4 times 2 minus 5. 8 minus 5 is 3. F of negative 3. It's f, so we use this function definition. So it's 4 times whatever's in the parentheses, 4 times negative 3 minus 5. Negative 12 minus 5 is negative 17. The answer there should be negative 17. What about g of x? What is g of 2? So what is g of 2? Remember, g of x is 3x squared minus x. So wherever there was an x, we now put a 2. We just fill in the blank. So it's 3 times 2 squared minus 2. 3 times 4 minus 2. Follow the order of operations. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication and division, and then addition and subtraction. So 3 times 4 is 12, minus 2 gives us 10. G of x minus 1. Well, this is tricky, because this time, whatever happens to g of x says whatever is in the parentheses. You say 3 times whatever that is squared minus whatever that is. So we have 3 times the quantity x minus 1 squared minus the quantity x minus 1. It's like fill in the blank. There was an x here, we take that out and put the quantity x minus 1. If you want to square a binomial like that, you write it down twice and you FOIL it. So you get x squared minus 2x plus 1. If you want to eliminate the parentheses here, use the distributive property. So that's minus x plus 1. Use the distributive property here. We end up with, in combined like terms, we end up with 3x squared minus 7x plus 4. Vertical line test. A graph represents a function if it is impossible to draw a vertical line that intersects the graph more than once. So let's look at these graphs. Can you think of a way to draw a vertical line? I've drawn several in there that will intersect the graph more than once. Our first graph, is that a function? Yes, it's a function. It passes the vertical line test. Every single vertical line that you can draw on this graph will pass the graph only once. Is this a function? No. I've drawn 3 vertical lines that intersect it twice. It is not a function. Is this a function? Yes, because every possible vertical line you could draw would intersect the graph at most one time. So let's look at this. Is this a function? Yeah, all vertical lines would intersect this graph only one time. So it passes the vertical line test. It is a function. What is the revenue if the monthly charge is $20? So our monthly charge is on the horizontal axis, what we usually call the x-axis. $20, go up to the graph, and then go to the side and read the revenue. The revenue is halfway between $60,000 and $80,000, so our revenue must be $70,000. What monthly charge will maximize revenue? So think about where the graph has the highest possible revenue. The maximum is here. What is that value? $100,000. That's the maximum revenue. And where will we achieve that? What monthly charge will give us the maximum revenue? Come down from the maximum, and you will realize that a $45 monthly charge will give us our maximum revenue. What is R of 30? R of X is the revenue, so what is R of 30? Look at your graph. When you put 30 into the graph as a monthly charge, what is the revenue? $90,000. And finally, we want to know what is R of 60. So if you put in $60, what is your revenue? It's also $90,000. Is that a problem to get the same answer for both of those? Nope, it's not. So our R of 30 is 90,000 and our R of 60 is 90,000. And that is the end of section 2.2.